Hello, everyone. Our second tutorial for today is the modern data stack by Bogdan Pirvu. He is organizer of Vienna Data Science Tools and head of data science at Novomatic. Welcome, Bogdan. I hope you will come also tomorrow at the conference, and I hope everyone will enjoy this tutorial.
Well, I have to come because I'm giving a talk, but yeah. So actually, we had people in the call all the time. I didn't realize. I was just preparing here some stuff. So everybody was seeing me all the time, actually. Okay. So I didn't realize this. So actually, this is the first time I'm giving an online talk in Zoom, and I expected I would see, all the participants' icons or something like this. Apparently, it's not the case. Maybe let me start with basically two announcements. Well, first, it's the first time that I use this type of technology, namely Zoom, for presentations. Before this, I was only using Teams. So if something goes wrong, please excuse me. And the second thing is, as you see, I'm in my home office, and my small kid, he was sick last night, so he was vomiting and having some virus in the stomach, and he had to stay home. He's sleeping now, but if he wakes up and needs something, I might have to leave and take care of him because I'm alone at home. So these are the first two announcements. Otherwise, yes, thank you very much for inviting me and giving me the opportunity to share this type, to share this knowledge at this conference. Yes, I think we should just dive into the subject. So today I'm talking about the modern data stack, and as a matter of fact, talking about this type of topic isn't something I would have necessarily predicted like a decade ago, because at that time I was still a physicist doing research in quantum physics, and these systems, they don't typically have a lot in common with the topics we're discussing at this data science conference. On the other hand, I was using numerical methods in order to study these systems, more specifically numerical methods in MATLAB. This is why the first time when I saw Andrew Ng's machine learning course on Coursera, I was immediately hooked on the topic. So the entry barrier for me was quite low. That's because a crucial part of my research at the university was the numerical optimization of certain functions. And as probably most of you at this conference know, function optimization is at the very heart of machine learning. On top of that, Andrew was using Octave in his machine learning course. And Octave is nothing more than the open source version of MATLAB. And as I told you, MATLAB has already been the tool that I have already been using for years. So anyway, one thing led to the other, and eventually I ended up outside of academia doing data science, or more generally speaking, doing data stuff. And maybe at least some of you had a path that was similar to mine, originally starting out somewhere else, maybe in physics or maths, and eventually ending up in data science. And maybe it was a little bit similar, maybe it went a little bit similar like I did, like it did in my case. So Andrew Ng or somebody else originally got us hooked on machine learning. We started playing with some models. Maybe some of us even did some Kaggle competitions, and life was generally awesome. Every day felt like this. However, quite soon we had to deal with the reality in our companies. We had to deal with real data, and we had to gather the data, clean it, prepare it, and what originally started with us copying CSV files to our laptops and doing all the data munging and data preparation in on the laptops, sooner or later became fully fledged data infrastructure. And data infrastructure has to be operated, it has to be maintained. And like that wouldn't be enough. What originally started out as small data or medium-sized data quite soon became big data, and that's even harder to deal with. So slowly but surely, life started to look more like this. And just in case you're wondering what this guy is doing up here, this was the best stock photo I managed to find when I was looking for the term Sisyphus. So Sisyphus, maybe as you know, this is the guy from Greek mythology who was punished by Zeus to push a rock up a mountain in all eternity. So maintaining data infrastructure, at least for me, at times felt like Sisyphean work. And this was the time before data engineering became a thing. So I don't know, 2016 to 2017. And of course, we didn't have any data engineers in our company to maintain and operate data infrastructure. So my small team and we had to do all this stuff on our own. So of course we had to do the data infrastructure maintenance and operations before we could get to the machine learning part. And of course we had to do it, in order to get to the machine learning part, but it just didn't feel great. So to put it in the words of a character from one of my favorite shows.
Like the stand-up comedian you have to sit through before Pink Floyd comes out.
And don't get me wrong, it's not that I didn't like the data engineering part per se, but this just wasn't the part that originally got me into this field. Or to put it in the words of another character from the same show.
Yeah, and it's not that we don't like the comedian, it's just that that's not why we bought the ticket.
But I have good news for you. Recent innovation has brought us to a point where life is getting simpler again. So you don't have to be a Hadoop engineer or a Spark Ninja anymore in order to operate your big data infrastructure before we get to the awesome machine learning part. We can bring Pink Floyd in directly. Or at least almost directly. So I'm talking about a set of architectural patterns and technologies that can make your life much, much easier. I'm talking about the modern data stack. And in case you didn't notice, this is not Pink Floyd. This is actually Aerosmith, but this was the best photo, high-resolution photo I could get with a concert. So you have to excuse me for this one. So anyway, let's look more closely at the modern. So let's dive into the modern data stack. And first, let's start with the name, which has become kind of a buzzword, very much like big data back in the day. So as you probably know, there are two ways to look at big data, or two ways to understand it. There is the theoretical explanation that goes along the lines of the 3 V's. We have volume, variety, and velocity. And at some point, people started to add more V's, like veracity and value. And actually, I never understood these V's on the bottom, because you should have veracity and value also in small data projects. But however, this is, these 5 points show up on the Wikipedia definition of big data, so I guess they have to be true. And by the way, speaking of Wikipedia, when I was looking for the term modern data stack on Wikipedia last year, when I was looking into these things, I didn't manage to find any page on the modern data stack. So I just went ahead and created one, which is still in the draft state, because Wikipedia has to approve any article that you submit. And it apparently is much harder to get something live on Wikipedia than I originally thought. So I'm in the second review round, and at some point, I guess I'll have to answer the questions that the current reviewer, or his objections. He has some objections about this article. So anyway, if you want to look modern data stack up on Wikipedia, you have to go directly to this link, because it's not It's not, the article is not live yet. It's still in the draft state. Okay, but there's the second way to understand the big data, not the theoretical one, but the one in terms of technology and in terms of the technology stack used in order to implement these projects. And of course, as probably most of you know, I'm talking about the Hadoop ecosystem. So the Hadoop ecosystem at its peak time was a remarkable success, because for the first time, companies other than big tech were capable of processing terabytes or petabytes of data efficiently on their own. Well, in the beginning, it was not so efficient because Hadoop was quite slow, but then with the advent of Apache Spark, it was quite efficient, and they managed to do things that were unthinkable before. However, operating a big data platform with Hadoop and Spark has, at least several downsides. So first of all, in the beginning, the cloud wasn't very popular. So what typical companies did was to host a bunch of servers in their own infrastructure and set up Hadoop on this on-prem cluster on their own. So you had upfront investments. Then probably nobody or no reasonable person would install Hadoop from scratch. Everybody had to take some sort of Hadoop distribution, and there were a few vendors providing Hadoop distribution. So you had additional costs for the Hadoop distribution license. And the third one, which is maybe the most important one, you needed really specialized data engineers like specialists in Hadoop and Spark in order to program and operate this cluster. And these are quite some downsides, some counter arguments. So big companies, big enterprises like my enterprise were capable to do this, but what would small startups do if they want to process huge amounts of data? And the answer to this question is our main topic today. It's the modern data stack. So what is the modern data stack? You can say the modern data stack, it's an ecosystem that started emerging around a decade ago with the release of the core technology in the modern data stack. And that technology is the so-called cloud data warehouse. So it cannot be overstated how important the cloud data warehouse was for the entire modern data stack ecosystem and for the entire tech ecosystem for that matter. That's because the cloud data warehouse offers you a unique mix of features that wasn't available before. So the first one is arbitrarily scale. So basically, if you go to one of the big cloud providers and instantiate your cloud data warehouse, you can store as much data in there as you want. So there is no upper limit. Well, there is some upper limit, but no reasonable company would hit that. But the limit for most companies is the limit on their credit card, which brings us to the second important feature of modern cloud data warehouses, which is the decoupling of the costs for storage and compute. So this means you can put really almost an infinite amount of data into your cloud data warehouse at a very reasonable cost, because as probably most of you know, the cost of object storage is quite reasonable nowadays. So you can just store all the data into there and analyze it later when you have some use cases. And maybe the third important feature is the usability. Cloud data warehouses have a much better usability than the big data Hadoop platform, because they provide a SQL interface. So you interact with your data strictly with SQL without having to write Java or Scala code in Spark. So there are a few providers for cloud data warehouses, and not all of them had all these features from the start. Some had a few of them, the others had the other ones. And in the end, eventually they all converged upon a core set of features. But let's look into the cloud providers and who these are. Okay, I see Q&A. Yes, so maybe we will answer these questions later. Maybe let me just finish this and we'll go into the questions later. So who are the providers of cloud data warehouses? So the first one, which was also the most important one for a few years, was Amazon Redshift. Amazon Redshift hit the market around 2012, 2013, and it was the product that established the entire market of cloud data warehouses. So Amazon Redshift was a huge success, and it was the single important player in this space for quite some time before the two other vendors, namely Google with BigQuery and Snowflake, managed to catch up because they implemented all these important features that we're having here. And more specifically, what Google didn't have in the beginning was the SQL interface. So the standard SQL interface was added to BigQuery in around 2016, and this was basically the time when BigQuery managed to catch up. And actually, what's a funny fact is that BigQuery hit the market before Redshift. So Redshift became popular even though BigQuery was on the market for already 1 year before Redshift hit the market. About Snowflake, I'm not quite sure why they were not very popular in the beginning, but fact is that at some point in around 2018, 2019, Snowflake basically exploded, and now Snowflake and BigQuery are at least as established as Amazon Redshift, maybe even more established, and that's because Amazon Redshift, so these two vendors, they caught up because Redshift was lacking one of these three features you're seeing here, namely it was lacking the decoupling of costs for storage and compute. So Redshift was basically, or I'm not entirely sure about the status of Redshift nowadays, but for a long time, it was basically some layer added on top of Postgres that managed to make Postgres horizontally scalable. And the problem with that was that when you instantiated Redshift in your AWS cloud, you had to select a number of VMs or number of VM instances where Redshift is installed upon. And of course, as a reasonable business that doesn't want to be offline, you have to provision this cluster for peak consumption. So maybe during the peak hours of your business, you needed some capacity, some number of VMs, I don't know, let's say 100, but during the most time of the day, probably you need much less. Still, you had to provision Redshift for peak consumption, and it could become quite expensive. This is why BigQuery and Snowflake were earlier than Redshift to decouple the costs of storage and compute, and this is why these two technologies caught up so much. And now it's a bit hard to get reliable numbers on the market share, but I would say they are maybe comparable, but I don't want to bet my money on this. And actually, I have a question. Do you see my cursor when I'm pointing like this, or do I have to? Is there a laser pointer or something? So Vuk, are you still there? Okay. I hope you can see my cursor in my screen sharing thing.
Yes, we can see.
Okay, so you can see my mouse. Okay, perfect.
Yes.
And the last technology to mention here is by Microsoft in the Azure cloud, which is also the most recent one. I cannot tell you much about Azure Synapse Analytics, except that probably they have managed to implement these features, or if they haven't implemented them yet, they are probably on their way to implementing all of them. But I won't be surprised if they already have implemented all of them. So Microsoft was quite late to the party, and for some time, some of the technologies that we will see in a moment from this modern data stack didn't have connectors for Azure Synapse Analytics. So some of the most important technologies we'll be looking at. And this is why, you know, I didn't use this and didn't look into it at all, basically. Maybe they have connectors nowadays, but I just didn't have the chance to do this. Okay, so much about the cloud data warehouses. But maybe let's back up a little and look a little bit into the history of storage solutions from their very beginning, because I think it's relevant to the entire discussion. So let's look at the history in a nutshell of data storage. And we'll start with the most, you know, with what was a huge milestone at the time, with the probably first really successful relational database, which was Oracle in 1997. I think even before Oracle, you had some other relational databases, you know, so you got stepwise to the Oracle database. I know of a quite ancient database which I used to work with, you know, at my first job during school. So that was a RIMA database, and I don't remember exactly what the big difference was, but it wasn't fully relational like Oracle. Maybe it wasn't ACID compliant or something like this. I don't know, but whatever. Oracle was the first really successful relational database. And when I you know, when I did the research for this talk, I was actually quite amazed that the other relevant relational databases like Microsoft SQL Server and IBM DB2, that these guys, they were quite late to the party. So probably SQL Server was released in '89, so 10 years after Oracle. So I was really surprised by, you know, this huge time gap between these two steps here. However, after this, you know, technology moved forward quite quickly. So 95, 96, you had the big open source databases, MySQL and Postgres, and these two, you know, they were quite, they had a big share of the success of what became, you know, the .com bubble and burst, and then Web 2, because as probably most of you know, Web 2 platforms like Facebook were at that time written in something called the LAMP stack, and LAMP stands for Linux, Apache, MySQL, and PHP. So MySQL and Postgres also, you know, were central components of these Web 2 applications that made, you know, the web really successful. So they were quite important at that time. And then with the big success of Web 2 and web platforms like Google or Facebook or whatever, we had an explosion of data that was collected. And by this year, 2005, these platforms were generating so much data that something new had to come along. So there is this paper by Michael Stonebreaker. Michael Stonebreaker was, you know, the professor who designed Postgres and Ingress. This Ingress was the solution before Postgres. And in 2005, he wrote this paper, One Size Fits All, an idea whose time has come and gone. And basically, the reason for this is because before this explosion of data, you could use these relational databases for both your use cases, for OLTP use cases, which is online transaction processing, which basically means you have these databases as the transactional databases powering your applications, and also for OLAP use cases, which is online analytical processing, which is what we as data scientists are interested in. So we are interested in analytical use cases. And before the explosion of data due to the internet, it was quite reasonable to do both transactional and analytical use cases in the same database. But by 2005, people started to realize you have to separate the storage solutions for transactional and analytical use cases. And at the end of the slide, you'll see the link to this paper in the footnotes. So we had this paper in 2005, and then shortly after that, so-called big data or NoSQL solutions emerged that were specifically well suited for analytical use cases. And of course, I'm talking about Hadoop. MongoDB, you know, is the, let's say, the most important example of document DBs. And it's kind of a strange animal because in the beginning, MongoDB was very attractive due to its scalability. So MongoDB being a non-NoSQL database could be horizontally scalable. Of course, you have to give up on the the relational structure, and on certain, you have to give up on this ACID compliance and these things that you need in any case for transactional databases. However, with the time, MongoDB started to add more and more features such that nowadays you can use it perfectly well as a transactional database. But still, it comes at the cost of having your data, not normalized and not stored in a relational manner. CouchDB is another popular document DB. Cassandra could never be used as a transactional database. It's strictly for analytical use cases, and it's a columnar database, where you can perform these analytical queries really efficiently. And also in this same time window, the three big Hadoop distributions emerged, which were Cloudera, MapR, and Hortonworks. So these were people that were offering, an easy way to install and manage a Hadoop cluster. Because without this kind of Hadoop distribution, you'd basically go crazy installing and maintaining a Hadoop cluster. So in the meantime, there was a huge consolidation here. I don't know what exactly happened to MapR. Maybe some other company bought it or maybe just disappeared. Anyways, Cloudera and Hortonworks merged, and nowadays you only have the offering by Cloudera. And as you will see in a moment, the market share is rapidly declining here. Okay, so we've had these technologies, and the funny thing is that in 2011, I think 2011 was the year when Google BigQuery hit the market, and then shortly after that, maybe 2012, Redshift and Snowflake was the latest to this party, well, except for Microsoft, but it was in 2014. So this is actually quite some time ago. It's over 10 years when this thing started, but these technologies weren't widely popular at that time. What happened in the meantime is that 2014 Apache Spark, which is the distributed computing engine on top of Hadoop, hit the market, and Apache Spark was a huge success because it replaced the rather slow MapR execution engine from in Hadoop with the Spark in-memory execution engine, which made this big data processing much more efficient. And Apache Spark was a huge thing before anybody, or at least me, or probably very few people heard about these technologies or used them, because they were just not they were not a hot topic. And actually, as Vuk said, I'm also the organizer of a meetup, which nowadays is called the Vienna Data Science Tools Meetup. And at the end of these slides, I'll show you a link where you can also join, and if you're interested in our next event. But the Vienna Data Science Tools Meetup was first called the Vienna Spark Meetup. And I think I started it in 2015. So in the beginning, we were just focusing on Spark because Spark was the hot technology back then. But at some point, we ran out of Spark and Hadoop speakers, and we had to rebrand it and focus on more broad topics than just Hadoop and Spark. Anyway, Spark was a huge success for a few years. Then between 2015 and 2017, these technologies hit the market, and these are also quite interesting technologies. We won't look into them today, but they are interesting because they are scalable databases or scalable storage solutions that you can use as transactional databases for your applications. So Spanner, CockroachDB, and FaunaDB, these are, you can store a huge amount of data into them, but they also provide you features like ACID compliance, such that you can use them as proper transactional stores. But if you have analytical use cases like we data scientists typically have, you wouldn't look into these technologies. You'd go straight ahead to a cloud data warehouse. Cloud data warehouses cannot be used for transactional use cases. It just doesn't make sense. Okay, in 2019, the inventors of Spark, these are people working at a company called Databricks, they introduced a new product, Databricks Delta Lake, which in principle can be used as a storage solution in your modern data stack. But it isn't exactly a cloud data warehouse. It is a data lake, or what some people like to call it nowadays, a data lake house, which, so these terms, they are fluid. It's not exactly clear to me where you have to stop something calling a data warehouse and call it a delta lake or data lake house. Anyways, in 2019, cloud data warehouses began to gain significant traction, especially BigQuery and Snowflake. Redshift was successful even before that. And in 2020, for the first time, the term modern data stack gained traction, and it basically, maybe some people used it before that, but it really became popular with the so-called Modern Data Stack Conference, which was organized for the first time in 2020, and this is organized by one of the technology providers in the modern data stack, which we'll see in a minute. It's a company called Fivetran. Okay, so let's try to understand the market share a little bit better of the cloud data warehouses, and it's actually quite hard to get reliable numbers, but let me show you, a proxy for actual market share numbers. And here I'm showing you some numbers from Stack Overflow questions over, more than the last decade. And I'm starting here with the classical big data technologies, with Hadoop and Apache Spark. And as you can see, here the rise of Hadoop, and questions on Stack Overflow peaked around 2015, and then they started declining. And this was incidentally the time when Spark really hit the market and gained significant traction. And you see here the explosion of Spark from 2014 until 2018. And now it's kind of declining. The questions on Stack Overflow are declining. And what I must say is that it's not the absolute numbers here that are important. What I'm interested in this plot, and what I want you to understand, is that it's the trend that is important. Because the absolute numbers, they are also correlated to how problematic a technology is. So, of course, if a technology is very popular but it has lots of problems, you'll have many questions on Stack Overflow. And this is the reason why you are seeing so many Spark questions, because it was very popular. It was the best solution for doing big data computation at the time on Hadoop, but it was also very difficult to use. This is why you see so many questions here. In contrast to these lines, I want to show you. Oh yeah. I want to show you the lines corresponding to the cloud data warehouse technologies. You see here, this is BigQuery 2012. Then you see Amazon Redshift 2013. And here the last line is Snowflake. And these numbers are much lower than the big data technology numbers. But what is important here is the trend. So it's rising, which means people, it's correlated to the number of people using it, but it's anti-correlated to the difficulty of using it. This is why these lines are much lower than the lines for Spark and Hadoop. But what's important here is the trend. And you see Redshift is below BigQuery, even though at this time in 2016, I think I read in some article that Redshift had about the 10-fold market share of all the other technologies combined. So here, 2016, Redshift was hugely successful. Still, it had roughly half the questions of BigQuery. So don't look at the absolute numbers, look at the trends. However, what's quite clear here is this step function-like jump in the Snowflake, which I assume it's related to its rise of market share rather than to difficulty of using it, because all of these cloud technologies, cloud data warehouse technologies, are rather easy to use. And the last one who came to this party is, well, not the last one, because Databricks was around for a long time, but their online, their managed offering, which is Databricks in the cloud, and also strongly correlated with Delta Lake. You see, it's growing here during the last few years. And as I said, Databricks is not exactly a cloud data warehouse, but it can be used as the storage layer in the modern data stack. And this brings us to the layered architecture of the modern data stack. So all of these cloud technologies can be used as the storage layer. But let's start with the source layer. So what do we have? So typically we have a bunch of source systems. This can be transactional databases that power your applications like Postgres, MySQL, MongoDB, MariaDB, or the more enterprisey ones like Oracle and SQL Server. This can be, huge ERP system like SAP, or other services that modern companies use nowadays, SaaS services like Shopify for online, for e-commerce, Salesforce CRM automation, MailChimp also for automation, or ads systems, Google Ads, LinkedIn. Okay, you can also connect Google Sheets and a bunch of other products, and you can also connect message queues like Apache Kafka, if your data happens to be in Apache Kafka. So these are data sources where data is residing or moving through them, like in the case of Kafka. And typically you want to do something with this data. So typically you either want to visualize it, and here we see the so-called visualization layer where you have BI tools like the more classical one, Tableau and Power BI, but also more modern SaaS-based solutions like Looker and Mode. And here we have two open source solutions that you could host on your own, Metabase and Superset. So either you want to gain visual insights from your data, or reporting basically, or you want to do something, you want to do predictive analytics using machine learning. And here I have put just these 4 logos, where the Jupyter logo stands for all the tools you have in the Python ecosystems. I don't even start thinking about putting all the logos in the Python ecosystem here. We just look at the Jupyter here. It's a placeholder for all the tools. And I've put the machine learning offerings of the big cloud providers into here, and it will become apparent a bit later why I've put them here. So you have on AWS SageMaker, on Google Vertex AI, and on Azure Machine Learning. And typically, if you don't have a lot of data, this is, this picture is enough for you. So if you have, some databases here, you could basically connect them directly to Tableau or Power BI, where at least, the databases. So you have database connectors in Tableau and Power BI that can connect to these databases. You cannot connect directly to SaaS services like here, but we will see in a moment how this is solved. Okay, so if you have small data, you can connect directly from the right to the left. But as soon as you have big data that that you have to put on a cluster in order to join the data together and analyze it downstream, what you used to do before the modern data stack was to put a big data solution based on Hadoop in the middle. So you would put a Hadoop cluster with Spark running on it in the middle. But what we are doing nowadays is the modern data stack approach, and that is namely to put a cloud data warehouse in the middle. So now we have this picture with the cloud data warehouses or storage solutions we've seen. And in principle, you could also go along with this picture, and this is what we've done for some time. We would write, custom Python scripts that would be scheduled on some machine, and they would run on a schedule and get the data from these data sources, put it into BigQuery, and then analyze it down the line. But this was quite cumbersome and buggy, and it was time consuming to maintain it and operate it properly. This is why a new set of tools became really popular over the last few years. These are tools from the so-called ingestion layer. And here you see a few SaaS offerings and so SaaS offerings are, for instance, Fivetran, Stitch, and Matillion. These are managed solutions in the cloud. Meltano, Airbyte, and PipelineWise are open source solutions that you could in principle host on your own. And additionally, Airbyte is offering a managed solution in the cloud. But these tools emerged because they are really, really useful. They take, they take all the work and difficulties that you have when you have to maintain and operate pipelines on your own. So in these tools, basically, the most advanced ones, you just enter the credentials to your source, you enter the credentials to your target, and you schedule these things, and they run totally smoothly. And most of the time you have no problems with them. And Fivetran was that vendor I was talking about before. Fivetran is the company hosting the Modern Data Stack conference. Okay, so we have this picture. So what we do, the data is taken by these ingestion tools from the source systems, put into the storage layer, and then we connect to the storage layer from BI tools or from machine learning tools. And if all what you're doing is to just ingest raw data and then access it directly here, this picture would be everything. But this is typically not what you're doing most of the time. What you are doing is to have, to do some data preparation in the storage layer, to do some joins or aggregation or whatever. And this is taken care of by the so-called transformation layer. In this transformation layer, you have several tools like DBT, LookML, and Dataform, where you can that provide you basically a really convenient way to define data transformations, which are then executed in the cloud data warehouse themselves. But these tools, they enable you to use best practices from software engineering to this realm of data engineering. And Dataform and LookML basically belong to Google, and the de facto standard nowadays, outside of the Google world, is DBT, and we'll be diving into DBT a bit more later. Okay, so we have this picture. This is also perfectly fine if you, if this works for your use cases. But turns out that big enterprises, they have additional requirements and use cases that require some tools that operate across all these layers. And these tools or these layers are, for instance, discovery and governance tools. And here you have a bunch of both SaaS providers of managed solutions as well as open source providers. You could need data quality and observability deployed along your pipeline, which which is highly which I highly recommend in order to take care that stuff doesn't go wrong and you are notified about, let's say, for instance, I don't know, if some distribution that you would expect to look in a certain way starts to be skewed due to some to some bugs, you want to be notified about this. Or of course, the most trivial things you would want to be notified is when data is missing, when certain columns are null that shouldn't be null, or schema changes, or these types of things. But the more advanced use cases here are looking at distributions and checking the data quality there. If you want to do stuff that goes beyond ingestion and what DBT and scheduling that is offered out of the box by DBT, you can use an orchestration engine like Airflow, Prefect, or Dexter. And this was actually for a long time how the data pipelines or the execution of data pipelines was scheduled in the modern data stack that was based on the cloud data warehouse using Apache Airflow. And it turns out, so there is a quite famous blog post which is called The Decomposition of Airflow. And in that blog post, basically the author took Airflow, and then he looked at different components or plugins for Airflow, and he managed to put all the plugins from Airflow into these squares you're seeing here, into these separate layers. So in the beginning, Airflow was doing everything basically, or you had plugins or components, and then certain plugins or components moved into these layers that you are seeing here. And if you need privacy and security that goes beyond what big cloud providers can offer you, you could look at this type of tools. And what you're seeing here is, an empty space here, and this is because this is the most recent layer in the modern data stack, which is the so-called reverse ETL layer. What this layer is doing is quite trivial. It's taking data from the data warehouse, so process data, transform data, and pushes it back to your operational applications. A typical use case would be based on the data from all your systems. You compute customer lifetime value in the data warehouse. You have it here as a column in the data warehouse, and you want to push it back into your CRM tool or marketing automation tool, such that you target only the highest value customers with this with your campaigns. And as you might see or think, ingestion and reverse ETL, these layers are basically doing the same thing, transferring data from A to B and then from B to A. So it's just data transport. And this is why we are already seeing some sort of consolidation in this space. So last year, Airbyte bought Grouperoo, which was also a company providing the. So Grouperoo used to be, at least at that time, an open source tool. I don't know what's going on here right now. Sensors and Hightouch are managed cloud solutions. Okay, so this is basically a high-level overview of the modern data stack and the layers that are contained in it. And basically, what I want you to understand is that you don't need to use all the technologies here. So basically, what you need, if you're lucky, you might get away with using one provider in each of the layers. So maybe you might get away with using Fivetran and BigQuery and Tableau and dbt. So you just need one provider from all of these, if you're lucky. If Fivetran doesn't provide you, all the connectors you need here on the left-hand side, then you have to use a different tool. And actually, we looked quite a lot into this ingestion layer. So we basically tried out, we started with Stitch, then we looked into Meltano, we looked into Airbyte, and eventually ended up using Fivetran. So, you have to look into your use cases, which sources you have, and what exactly you need. There are pros and cons of all technologies. Fivetran is quite expensive, but it's also quite good. The other ones are, more affordable, but they don't offer as many features. And maybe the most important tool from my perspective in this entire image that you're seeing here is dbt. And I want to look a little bit deeper into dbt at this point. And unfortunately, if we would be a live audience, I would ask you, who of you have already heard about dbt? Who of you have already been using dbt? And you would show up and, I would make a comment. But my final comment would be that dbt is really great. And I am deeply convinced that dbt is one of these transformational technologies, like maybe not as much, of course, not as much as Git or as Python, but in the realm of data analytics it's probably just as transformational and as relevant. And most companies who want to do analytics efficiently will end up using the modern data stack over the next few years. And most of these companies will be using dbt for the transformation layer. So why am I saying this? Why is dbt so great? So dbt, so let's see. So the first reason is because in dbt, you can have your entire transformation layer as code. So you write code in SQL and you store it in files, basically. So the models you define. So whenever you define a transformation, this is called a model, and the model is basically the output of a SQL statement. So you define all your models in SQL, but not only in SQL, because dbt offers something on top of a standard SQL, which is Jinja templating for additional logic on top of SQL. And because you have the entire transformation layer defined as code, you can obviously do version control with Git, which enables other good things like using best practices from software engineering, like automated deployment after code changes, automated testing. What DBT also provides is automated generation of documentation and data lineage. And during the demo, we will look into this a little bit. And maybe the greatest thing that DBT provides, or the most valuable thing for all kinds of enterprises and startups, is that you can take your analysts, and by analysts, I'm referring to people who know how to write SQL, but who are not, who don't have a background in software engineering and coding. So you can take these people and upskill them a little bit with DBT, or they upskill them themselves. And these people, they can become something which is called an analytics engineer. And an analytics engineer, this is a role, it's a term that was coined by the company behind DBT. So an analytics engineer is a guy who knows SQL, who knows DBT, and who can be used as basically what used to be a data engineer in the big data Hadoop world. So you have this analytics engineer maintaining your data pipeline and being in charge of your data infrastructure without him having to be a coder. So knowing SQL and DBT is enough. And this is, I think, the biggest value, because good Hadoop and Spark engineers are really hard people to get. And nowadays you don't even have to get them anymore, because you would use DBT in a modern data stack. And actually the company behind DBT, what are they called? DBT Labs, I think. So they organized this conference, which is called Coalesce Yearly Conference. It's the annual conference dedicated to the advancement and practice of analytics engineering. So these guys, they invented this term, analytics engineer. So this is a highly desirable role for people. And the last thing is that, at least to me, it seems DBT is quite easy to learn. They have a great documentation, they have a great Slack channel, and this feature enables this transition here, enables this thing to be really smooth, the transition from an analyst to an analytics engineer. Okay, so let's wrap it up. What are the advantages of the modern data stack from my perspective? So it's quite easy to spin up. You just have to provide your credit card and instantiate the services, ingestion, storage. For the transformation layer, actually, I forgot to tell you, DBT is an open source tool. You don't have to use the paid version. You can run and execute it on your own laptop, but they have a cloud-based managed offering that is even easier to spin up than on your own laptop. So the modern data stack is easy to spin up. It's cost efficient, basically because actually for two reasons. Basically because you have this decoupling of storage and compute on the cloud data warehouse level, and because you can have analytics engineers rather than proper Hadoop data engineers, and you save HR costs there. And this is actually the third, so this is the third important thing. You can have analytics engineering, and this goes back to the cost efficiency. And it's not only cost efficiency, it's because even if you had all the money in the world, you can hire so many Hadoop and Spark engineers because they are just so rare. So these are the main advantages of the modern data stack. As you see, I'm pretty excited about this topic. It makes my life and the life of my team much easier. And I'm quite confident that if you haven't already, that if you give the modern data stack a try and maybe build a small prototype, you'll be very impressed, and you'll end up falling in love with this approach as much as I did. At this point, I say thank you for the presentation. Let me check what's next. Okay, so these are the references. Let me think how I do this. So maybe let's do the questions here at this point, and then we'll look into the references and into some other stuff. Vuk, are you moderating, or should I just do this stuff? Oh, whatever. Oh, no. Let's see. What are your thoughts on? So do you see when I open this window? Do you see my entire screen?
Yes, yes. No. We are seeing only presentation.
Ah, I see. So we have a question here. What are your thoughts on proprietary ELT, ETL, and the combined unavoidable vendor lock-in?
Are there any questions?
Yes, I see them.
Yes. Okay, sorry.
So I just read the first one. I hope you heard me. So the question on proprietary ELT, ETL, and I assume you're referring to the ingestion engine, I assume, because the T in the ELT, ETL, this is a transformation. You would do it with DBT anyways, and this is open source, so there is no vendor lock-in there. It's just a technology lock-in, but this is us saying, well, I'm locked in into usage of Python. So if you're locked in into usage of Python, you're pretty, well, you're not locked in because you're using Python anyway. And it's the same with DBT. For transformation, you use DBT anyway. So for the transformation, you're not locked in. For the ingestion, yes, you are kind of locked in. But I have to say that most of these ingestion tools, they have a very big feature overlap, and they have a big overlap of the connectors that are provided, but there are still differences. So let me tell you an anecdote. Maybe let's just go back to this slide. Well, so I told you we used all of this, and for a good reason. And we at Novomatic, I didn't present my company, but maybe people from Austria know it anyways. So we are one of the biggest providers of casino technologies and one of the biggest operators of casinos worldwide. And we have a project to integrate the data from all our operational sources from many countries across the world, from many casinos, and each of these casinos, they have their own so-called casino management system that has its own transactional database, which can be either one of these technologies here, MySQL, MariaDB, Oracle, SQL Server, Postgres. We have all of them, and we have to connect each of these components, which is already a challenge. But what's even more challenging is that these casinos, they are operated by separate companies. They are not the company where I'm working at. So I'm working in the headquarters. This is the so-called, a holding company, and customers give their data to the subsidiary companies, and they give their consent to data processing to the subsidiary company. And since the GDPR, in the entire Europe, we are not allowed, to transfer data from country to country and process personal data for other use cases than the ones explicitly agreed by the user, or the ones that are called, I forgot what it's called, proper interest or something like this. However, so these casino subsidiaries, most of the time they refuse, and with a good reason, to share personal data with us. And it turns out this places some restrictions on the type of replication you can do along this line. And in the end, at the current state, we managed to do what we wanted to do, only with certain technologies from here. So we had to get rid of many options, and in some cases we have to use Fivetran, which is it has the most features, but it's also the most expensive one. And there's always you have to look at cost and what you get for your buck. Why am I saying this? Yes, for some use cases we are now currently locked in with Fivetran, but there is no other option. So the other things are just not working for what we're trying to do, and that's life. But let's say for more down to earth use cases where you are yourself the operator of the source systems, you don't need to use these special features in Fivetran, so you can pick either one of these. And regarding to this question of the ingestion tool lock-in, this lock-in is not, so you're a little bit locked in, but it's not so painful because spinning up these tools is really easy. So it's easy to replace them. If two tools have the same features that you need for your pipeline, then it's really easy to replace them. Okay, let's see. Next question. I hope this answers your question, and if not, then just provide here more answer in this chat. Let's see. Can we get this presentation? Yes, you will get PDFs afterwards. Somebody is thanking. Thank you very much for the thanking. I have one question. Does R also play some role in your opinion? So for me, it doesn't play a role. So I gave it a try many years ago, and I used to be a quantum physicist, but I never used R. And before that, or during that time, I was also a software engineer. So I have more of a software engineering approach to this, and Python is for software engineers, the much better tool. If you have a statistics background or life sciences, of course you want to use R, and obviously you can use R for machine learning. So if that's a tool you're happy with, then that's what you should take. I would like to ask if you could state the advantages and disadvantages of using only one cloud provider's ingestion, storage, transformation instead of connecting them. Well, it turns out for big enterprises like mine, you cannot use one cloud anyways, because we have different business units and we are already using different clouds. And, we cannot say we just go with this cloud because we use all of them. And even if at this moment we would be using just one cloud, big companies like mine, they are acquiring other companies all the time. And if you buy a gaming provider who is in a different cloud, you don't want to have the effort to migrate everything into your own cloud. So this is why we just have to live with the multi-cloud environment. The advantage of using cloud tools, like for instance, discovery and governance is a good example. So you have Dataplex on the Google Cloud, you have Azure Purview on Azure, and you also have something in AWS, which is not entirely clear to me if it's equivalent in terms of feature parity. But you have these other providers like Collibra and Atlan and Alation. These are managed providers, SaaS providers. The advantage of using the cloud native services is that they're just much cheaper. They're just they're much more cost efficient than using Collibra, for instance. Collibra is a great tool, has many features. It also costs a hell lot of money. Or if you're really hardcore and you have the talent in your company, you can go ahead and use an open source tool like Amundsen or DataHub and host it on your own. But only if you have a big team who's capable of operating these things. We are a small team. This is why you have to automate and use as many managed solutions as possible. I hope this answers your question. Do you think the analytics engineer as a role is one which would compete with new ML-driven approaches? I'm not sure I understand the question correctly, but you can ask GPT. So did I read it again? Like GPT-4. So the question is, how do I understand this? So are you asking if GPT will take away the jobs of analytics engineers? Because if you're asking this question, I don't think it will take away the jobs. I think it will make analytics engineers much more efficient. It's making me much more efficient. So now when I write code, most of the time I ask ChatGPT how the function should look. It will make you more efficient. It will make people who use these tools much more efficient. And I'm not sure if the volume of work will increase in the same manner, such that the increase in productivity results in a steady balance. But we'll just see. So I'm not at all concerned about this. So I welcome all these tools that make you more efficient, and I think everybody should do it just the same way. Oh yeah. Next question. Data ingestion and data transformation via AWS Glue. Yes, Glue. What do you think about it versus ingestion and transformation tools that you mentioned? So, So basically, yes, Glue is a cloud-native ingestion and transformation tool. We briefly looked into it, but we immediately had recognized that it's not good for our use cases. We also looked into the cloud-native service on Google, which is called Data Streams, I think, or something like this. That also didn't work out for our use case, and basically the reason there was that that tool provides change data capture replication, which is in principle is the best way to replicate your data. So change data capture goes to your database and reads the op logs and does the replication based on the op log, which is the most efficient thing to do, because you don't create load on your source database, because you don't execute SQL queries. You just read the op log and replicate it into the target. Unfortunately, maybe I just mentioned this one problem, and it's one of the many problems that we have. So unfortunately, we had to ingest data from MariaDB, and from a country, let's say it was Romania, because it was Romania. We had to ingest MariaDB data from Romania, and this data in the original database contained personal information, personally identifiable information. These guys didn't want to give us access to this information, which is their good right, or is their how do you say, whatever. So they have to do it in any case. And so the solution they provided to us is to provide us a read replica of MariaDB, where they created a user which had a restricted access to some tables. For that user, they just they removed the access to certain columns that contain PII data. So we had the original MariaDB cluster. We had a read replica of that with a certain user specifically for us. And the thing is, if you have a CDC engine like the Google Data Streams, I hope I get their name right. This engine has to be connected to the main database. You cannot connect it to a read replica, because you have to set all these replication settings on the master main database. So this was actually basically the use case that ruled out technologies, CDC technologies like data streams or other CDC technologies for this use case. So we had to go with a solution provided by Fivetran, which is something called Teleport Sync, which is some sort of smart way to compare the data in the source and the target, and just do a sync whenever the data is different. And apparently it's an efficient way. So we have to evaluate it more deeply, but it's not as stupid as reading everything and just doing a full sync. It's more efficient than that. I don't know by how many percent is more efficient. Maybe it's 20, 30, 40. I'd be happy if it's 50% more efficient, but we have to look at the data. I hope this answers your question. Do you know any feature store in your data science setup of ML ready? Yes, so actually this is actually a new layer, which you don't see here. It's called the, you can call it semantic layer or metric layer. And LookML, as far as I know, LookML is a tool where that can be used as a feature store. And let me tell you how I understand this. And it's a pity that we're not in person, because we could have a conversation. But how I understand this, you don't need this abstraction all of the time. So you need a metrics layer abstraction only when you are using separated downstream tools like different PI engines, like use Tableau and LookML, Looker and Power BI, and you want to standardize the access of these PI tools to the metric layer, to the metrics layer. If you're just going with one BI tool, you don't necessarily need this thing. So the question, I'm not up to date with the feature stores, so I have to pass on this one. But LookML is certainly one of the more popular ones, and maybe there are more out there. Next question. So actually, I also wanted to do a demo. Maybe I just take one more question, then we move to the demo, because otherwise everything's gone. Okay, so here's a long one. I'm not going to take the long one. I'm just going to take the short one here. There's a lot of talk about data meshes this day. Where would you place them in your overview slide? So a data mesh is an architectural principle that you can certainly implement with the modern data stack. But data mesh, is much more about organizational, let's say, change. You have to set up specific contracts with your organizational units and interfaces and establish data contracts. So this is actually the main idea of data meshes. It's an organizational challenge. And when you solve the organizational challenge, you're pretty good. And on the technical side, the technical challenges can be solved with modern data stack or with whatever other kind of architecture you want. But of course, I obviously recommend the data stack. Okay, so thank you for the questions. Maybe let's move quickly to the demo and to the next slide. So we have here, so you will get the slides afterwards. Here you have references to the modern data stack and DBT. So keep in touch. I want to advertise a few things where you can, where I'm happy, to see you and to keep in touch. So first of all, we have a really small currently modern data science group on LinkedIn, but I hope this will grow and over the time, and we have some meaningful conversations there. Then what I already advertised is our Vienna Data Science Tools meetup, which used to be called Vienna Apache Spark meetup, but now it's Vienna Data Science Tools. And we have the next event in the beginning of May, and so we have basically this collaboration with the Data Science Conference and VUC. Thank you very much for this opportunity. So if you're from Vienna, we are happy to see you there on the 3rd of May. The first talk will basically be what I was just talking about. So it will be the first talk, but we have 2 talks. The second talk will be somebody from Google making a deep dive into Google BigQuery. So yes. I'm happy to see you there, of course. And the last one is the personal link. So just get in touch and, keep in touch and lead the conversation. Okay, and now let's look at the live demo. We have 20 more minutes. And basically for the live demo, there's something that I quickly spinned up yesterday, basically. And I used to do these types of live demos with data from Twitter. Unfortunately, Elon Musk, basically switched off the free Twitter API, and I was too greedy to spend $100 per month to get access to a Twitter API. So I had to come up with a different solution, and with a different data source. And what I did is to use data from a side project of mine. I have, next to my role at Novomatic. I also have a small SaaS business, which basically it's a SaaS service for online tickets. When you go to the doctor, that you can book your ticket online and such that you don't have to wait in the room at the doctor's place. It's called Wartenummer.at. People from Austria know how big a pain waiting times of doctors are. This is why we did this as a side project in our spare time. And I'm using data from the staging system of the Wartenummer, of the Wartenummer project. So basically, the modern data stack will be looks like this, and this is how typically stuff looks. So we have a transactional database, which is MongoDB. This Wartenummer app is implemented with the so-called mean stack, just like the LAMP stack in the old days. You have, during the last decade, this mean stack emerged, which is mean stands for Mongo, E stands for Express, which is a web framework, A stands for Angular, the front-end framework, and N for Node.js. So it's a mean application with MongoDB as transactional database. And what I also set up yesterday is a new MailChimp account. This is marketing automation, where I entered a few, a few fake email addresses. And I'm using Fivetran to ingest the data into BigQuery, then doing transformation with DBT. I also set up a small dashboard or a small report in Tableau, and this I hadn't time to do, but probably most of you at this data science conference know how to hook up Python or Jupyter to BigQuery. So they have good documentation. So maybe, so I'll do now a different screen sharing and go through all these tools briefly with you. Let's see, is this the last slide? Oh yeah, and down here, I don't have anything. It's just this path up here. Okay, this is the first slide. So let me stop the sharing. Stop sharing. And let's do a fresh sharing. Yeah, screen. Okay, how the hell am I supposed to find the correct window here? Oh, this one. Yeah, so Zoom isn't offering me this window. Okay, whatever. I just do full screen sharing. So try not to pick at other stuff. Okay, so we have, what do we have here? So let's look at the BigQuery. So I'm not sure how many of you are familiar with the Google Cloud Platform and BigQuery. There are a few intricacies here, but let me briefly explain this stuff. So here is the, I have to minimize this. So here's the interface, the Google BigQuery interface, where on the left-hand side, you have a bunch of data sets. And these are in some, sandbox environment that I use. It's called Wartenummer test. And what we have here for this tutorial are a few data sets. We have this data set, which is basically the replicated data from my staging database of Wartenummer, this MongoDB. We have a data set which is called MailChimp, which is data ingested directly from the MailChimp SaaS service. So this is basically the raw data, and we have a few layers of transformed data on top of that. And maybe let's look into one of these tables, into the users table. And this is fake data on the staging systems. But anyways, what tools like Fivetran or other tools enable is that, for instance, when you replicate data, you hash sensitive data. So the emails would be in clear text, but these fields are hashed here. And a few fields you keep as they were, but the sensitive fields you hash. And what can I tell you? See, we have 233 rows here. Let's look at how this looks in Fivetran. Okay, and in Fivetran, this connector is actually this one here. So let me show you a few things. Here you see the data syncs. You see I've scheduled this to run every 15 minutes. And the setup is really, really easy. This is what makes these tools so efficient. So first of all, you have to set up a data target where you basically insert your BigQuery credentials, something called service account JSON file. And then you set up the data source, which in this case is MongoDB, and you just have to fill out a few fields here, like maybe let's start down here. So I'm connecting via an SSH tunnel to some IP address, using this public key, Fivetran public key, and there I connect to localhost because I'm connecting via an SSH tunnel. I have the MongoDB credentials, and then you set up one of these replication modes, and then you're good to go. you go save and test. Then Fivetran is asking you which tables you want to replicate. And we'll look at this in a moment. Come on. So you have the schema, and in this schema, you can decide which tables you want to replicate, and you can deep dive into it and, block certain columns or hash columns. So you see the password is blocked, for instance, and these other things are hashed. Why are they hashed? They are hashed because Fivetran does the same hashing on the same string, and then I can use these hashes to join the data from my MongoDB, like, where is it? Email. So I can join this email from this MongoDB table with the email that I have in MailChimp. Let's see. Remember. So here I also have a table where the email address is hashed. And then I can, I can just do a join on this email address and run my analytics. So this is basically why you would do hashes on this PII data. So MailChimp is even easier to set up. So in MailChimp, this connector is much easier. So basically here you just have to log in with your MailChimp credentials. So let me just briefly show this. So test, select, MailChimp, setup. You define the destination schema. You see, I didn't even change it, but here you can enter whatever you want. So this is the name of the data set in your BigQuery, and then you authorize, you log in with your MailChimp credentials, and that's it. Fivetran automatically, maps all the relevant tables from the SaaS service into here. So I think this is really amazing, basically. So if your business is using just these SaaS services like Shopify, MailChimp, Salesforce, some ads services, you just create these connectors in Fivetran, and then you have all the data in the cloud data warehouse. And what you have to do next is obviously is to do the transformation here. And we have 8 more minutes, so let's briefly look into the DBT. So I'm using DBT Cloud for this purpose, and whenever you start a DBT project, you can either do it locally on your laptop or use DBT Cloud. I'm using DBT Cloud because it's easier to spin up, and there are a few relevant things. So when you set up DBT, the first thing that you have to do is to set up your target. And if you use DBT locally, you do it in a configuration file in your home directory. If you use DBT Cloud, you have here some configuration settings. I actually forgot where it is. So DBT asks you, the first thing you do when you set up a DBT account is to set up the target. Well, okay, I forgot where it is. But at some point you have to upload a service account, a Google service account JSON credentials file, and that file I can show it. I can briefly show it to you here. In the case of the Google Cloud, let's see, where do I have the IAM service? So basically, you have to define a service account in your IAM console and give it the correct rights. Here we have, well, so this account. So I have the DBT user, which has these permissions: BigQuery editor, owner, job user, etc. And in some other place, I have to create a JSON key file, and then you take that key file and upload it to the DBT Cloud, and then you're ready to execute DBT transformations. And maybe the first file to look at is the DBT project YAML. And this DBT project YAML, forget this stuff up here. This is just generic stuff. What is interesting here is this section where you define the models. My new project is generic, but then we are defining how various folders in the DBT project shall behave. And these folders, I'm talking about the folders in the in this models folder here, I define all the transformations. And what I'm basically saying here is that all the models coming from the staging folder, they should receive a data set in BigQuery where we have this appendix from the intermediate layer, this appendix, and for the marts layer, no appendix, but I want to have this materialized as view and not as a table in dbt. And one of these links here is actually something that I wanted to show you. So basically, there is really good documentation online on dbt, and this is one of the links I would really recommend to you if you're looking into this. So this is how the dbt folks themselves recommend to organize the dbt projects. So they have various layers in their cloud data warehouse. So basically, you have the raw data somewhere that is ingested from Fivetran, and you don't change the data, you just leave it there. What you are doing on top of that is to define a layer which is called staging. And in this staging, you can either fix data types or fix column names and things like this, and also do some consistency testing. Then on top of staging, you have a layer which is called intermediate. Here you can do some intermediate transformations. You don't need it all the time, basically. What you should have is staging and marts, because in marts you have the data that is consumed by somebody else, that is consumed by the Tableau team, or consumed by the machine learning engineers, or consumed by whatever comes downstream. So you need staging and marts. And in my BigQuery project, this is what you see. This is the raw data coming from Fivetran. I should have given it some different name to know that it's Fivetran, but this is data coming from Fivetran. Then I have the staging layer, which is this one. And on top of the staging layer, I have an intermediate layer, which you don't need in any case. I just put it here for your demonstration purposes. And then the last one is the data mart, which, as you saw in that definition file, doesn't have a dataset appendix. So you don't see here anything at the end, and where the models shall be stored as views. And here, this is the symbol for a view in BigQuery. And here you have the symbol for a table. So this is data persisted in BigQuery. This is data, it's just a view, it depends on your use case, what you want to do, if you want to have the data as a view or as persisted. Okay. And what you're seeing here is just, so what you're seeing here is basically in the staging layer, I'm just picking a few columns out of all the original columns. So in the original table, where is this stuff? Okay, in the original users table, you see I have a bunch of columns here. And in the staging table, what I'm doing is to transform names. For instance, this ID goes to user ID, and I'm just selecting a few of the columns. And this is basically what you need, because you don't need all the time all of the columns from the original database, especially because Fivetran is adding some stuff to your data that is ingested. So for instance, it's adding this column Fivetran deleted, because Fivetran doesn't do hard deletes. It just does a soft delete. It just puts a true in a row if a row is deleted. So it's never removing data from BigQuery. And then you have, for instance, this stuff like Fivetran synced when the row was synced. These are basically the two only things that are added by Fivetran. And let's see how this is done. In these models, this is conventional. Okay, I have a folder where I define where the raw data is coming from, and I say the raw data for my dbt transformation is coming from this data set, and I'm looking at these tables in that data set. And the nice thing in dbt is that I can reference these things that are defined here directly in SQL in this Jinja format. So if I'm going to staging, let's see how users look like. So this is also convention. This is SQL, well, SQL plus Jinja. And what we're seeing here, and this is SQL that must be executable in your cloud data warehouse. So here you would be using the SQL dialect of BigQuery, and BigQuery is not standard SQL. It contains the standard SQL, but it also has a bunch of very useful add-ons on top of that. So here I say which source as, and here I'm referencing the model in dbt. And this is actually good practice to say, I'm just interested in rows that have not been deleted. This is why I have to do this initial, this initial query here, where Fivetran deleted is false. And then I do a select with the renaming. And this is basically the content of the users, of the staging users table. And what DBT is doing under the hood, it's understanding the data lineage. It's understanding how these tables are related to each other. And let me just remove this update graph. Okay, so you see here my transformation layer. We have the raw tables ingested from Fivetran. Then we have some staging tables here. And I have one table where I'm joining in the Marts layer the data from staging. And I see our time is up, but maybe as the last thing, let me show you. So what you have here is integrated Git control. So such that you can do version control in your development. You can create a branch, merge it. It doesn't have the full Git features that you would have in your IDE, but it's a basic Git version that you can get along with. And the interesting thing is the deployment. So here you have a command line where you would execute these models and they would be automatically executed in your data warehouse. You would do something like dbt run, and then it would go through all the models and execute them in your data warehouse. Here you will see an error if there would be an error, but there will be no error because this ran yesterday evening, so it's also running now. And the nice thing is you can do a deployment here. So you define a production environment, and if you have a production environment, it needs the type deployment, and then you can schedule it. Let's see, the jobs, we have this job here, and it's scheduled to run hourly. And I'm not sure, because this is a free DBT account, I would hope that in a paid DBT account, I can schedule this more than once an hour, because here I can schedule just once an hour. But well, that's that. And you see the run history, because there are two things in DBT. So if you define a model as being persisted as a table, you have to execute dbt run, because data needs to be pulled and then somehow transformed. If you define everything as view, you don't even have to execute dbt run, and you don't even have to use it, define it on a schedule, because the views are generating the data dynamically all the time. So you don't have to execute it. But the downside of this is every time when you run a select on a view, you generate computation cost in Google BigQuery. So, you have to look at the use case and decide, do I want views or do I want tables? And if I want tables, I need to somehow schedule dbt. And if you want to schedule dbt, you can either do it here from dbt cloud. If you're running dbt locally, you can do it from the cron job. And there is a really nice recent feature in Fivetran where Fivetran can schedule your dbt jobs. You can connect Fivetran to a Git repository containing a valid dbt transformation layer, and then Fivetran automatically schedules dbt when Fivetran has seen that data has been updated. Okay, guys, so I'm already over the time. Vuk, how should we proceed? Should we take more questions, or shall we just stop here? Is Vuk still with us? You're muted.
Oh, sorry. Yes, we don't have any questions now, but we had before, and we are glad that we had you as a tech tutor, and it was really amazing and really interesting and useful. And I hope that we will bring our collaboration on some higher level for some future conferences of your meetup and data science conference.
Yes, would be great. I will provide you the slides as PDF to share them via email afterwards.
Great. Yes, there was one question to Elena. Could you please post these links to the chat? Okay, we will send everything later.
Yes, so you have everything in the slides. And tomorrow I'll be giving a talk at the main conference, so I'm happy to see you there. I'll be talking about a different topic, large language models, and how you can develop apps with large language models.
Great, and I believe it will be also amazing like this.
Well, let's see. We'll see tomorrow.
Thank you, Bogdan. we need to create some, we need to have some break now because in 10 minutes we have another tutorial. But really, it was really useful, and see you tomorrow at the conference.
Yes, thank you for the opportunity to talk here and share these ideas that I really, I really like these ideas and this approach.
Thank you.
Have a good day. See you tomorrow.
Bye.
Bye.